implicit differentiation. Here, first we have to differentiate both sides of the equation with respect to x, treating y as a differentiable function of x. The next step, collect the terms with derivative of y with respect to x on one side of the equation and solve for derivative of y with respect to x. What we have here on the spot is the profile of a lens showing the bending or reflection of a ray of light as it passes through the lens surface. Here on the spot we have curve of lens surface. Here we have light ray, and the spot is point of entry. Here we have tangent line, and this one is normal line, which is perpendicular to tangent line. Use implicit differentiation to find derivative of y with respect to x. So here on the spot we have to differentiate both sides of the equation with respect to x. So derivative of x cubed with respect to x, that is 3x squared. Here derivative of 12xy is negative 12. And here we have x times derivative of y with respect to x plus y times derivative of x with respect to x plus derivative of y cubed with respect to x is 3y squared times derivative of y with respect to x equal to derivative of 1 with respect to x is 0. Now we have to solve for derivative of y with respect to x. So this is 3x squared minus multiply. So here we have negative 12 times x derivative of y with respect to x minus 12 times y. And here derivative of x over derivative of x, that is 1. So we have negative 12y plus 3y squared dy divided by dx equal to 0. And what we have here is 3x squared minus 12y equal to dy over dx times 12x minus 3y squared. So dy divided by dx is equal to 3x squared minus 12y divided by 12x minus 3y squared. I can factor 3. So here we have 3 times x squared minus 4y. Denominator, here again, factor of 3, and we have 3 times 4x minus y squared. So we can cancel 3, and this is equal to x squared minus 4y divided by 4x minus y squared. And here is our final answer. Use implicit differentiation to find first derivative of y with respect to x and second derivative of y with respect to x. Here we have 4x squared plus 3y squared equal to 4. Here derivative of 4x squared is 8x plus derivative of 3y squared is 6y times dy divided by dx is equal to derivative of 4 is 0. Now solving for dy divided by dx, that is equal to negative 8x divided by 6y, and that is negative 4x divided by 3y. Now second derivative of y is equal to derivative of negative 4x divided by 3y, and this is equal to negative times derivative of 4x divided by 3y, and that is equal to negative. Here we have 4x, so derivative with respect to x is 4 times what we have in denominator, so it's 12y minus 4x times derivative of denominator. Here we have 3 times dy divided by dx. And here in the denominator we have 9y squared. Using what we had here on that part, it's 3y and power is 2, so it's 3 squared y squared, so that is 9y squared. And this is equal to negative 12y minus 4x times 3 is 12x, and instead of dy divided by dx, I'm using this one. It's negative 4x divided by 3y divided by 9y squared, and that is equal to negative 12y plus 16x squared divided by y. So here what I did, 12 divided by 3, so that is, here on top we have 4, and then negative 4 times negative 4 is positive 16. And denominator here we have 9y squared. Now I'm going to multiply both numerator and denominator by y. So this is equal to negative 12y squared plus 16x squared divided by 9y cubed. So here is our final answer for second derivative. The given point is on the curve. Find lines that are tangent and normal to the curve at the given point. So here we have 3x squared plus 5xy plus 9y squared plus 14y minus 3 equal to 0. And our point is negative 1, 0. So here derivative of 3x squared is 6x, and plus here from derivative of 5xy, that is 5 times x times dy divided by dx plus 5 times dx divided by dx plus derivative of 9y squared is 18y dy divided by dx plus derivative of 14y is 14 dy divided by dx. Derivative of 3 is 0, and derivative of 0 is 0. Now solve for dy divided by dx, and here we have 5x plus 18y plus 14 times dy divided by dx plus 6x plus 5y equal to 0. So dy divided by dx is equal to negative 6x minus 5y divided by 5x plus 18y plus 14. Now we can find slope using derivative. So here dy over dx at negative 1, 0, we have negative 6 times x is negative 1, minus 5 times y is 0, denominator 5 times x negative 1 plus 18 times y as 0 plus 14. So this is equal to positive 6 minus 0. So that is 6. Denominator we have negative 5 plus 18 times 0, that part is 0, then plus 14. So here we have 6 divided by 9, and that is 2 over 3. So our slope is 2/3. And now here our line for part A is y equal to 2/3 times x minus negative 1 plus 0. So our point was negative 1 comma 0. And this is in point slope form. So it's y equal to 2/3 times x plus 2/3. Now part B, the normal to the curve at negative 1 comma 0 is a line perpendicular to the tangent at negative 1 comma 0. So the slope of the line is negative 3 over 2. That is negative reciprocal. So here in this case, our slope is, instead of having 2/3, now we have negative 3 over 2. And our line is y equal to negative 3 over 2 times x minus negative 1 plus 0. So point slope form is y equal to negative 3 over 2 times x minus 3 over 2. So this is final answer for part B. Verify that the given point is on the curve. Find the lines that are tangent and normal to the curve at the given point. So here we have 10xy plus pi sine y equal to 131 pi. And our point is 2 comma 13 pi divided by 2. So here I verify the given point. We have 10 times 2 times y is 13 pi divided by 2 plus pi sine y is 13 pi divided by 2, and that is equal to 131 pi. So we want to see if this is true or not. So 10 times 2 we have 20, 20 divided by 2 we have 10, 10 times 13 is 130 pi. Plus pi sine 13 pi over 2, that is 1. So here we have 130 pi plus pi. So here on the left side we have 131 pi, and on the right side we have 131 pi, and this is true. Since the equation is true, point 2 comma 13 pi divided by 2 is on the curve 10xy plus pi sine y equal to 131 pi. Part A, to find the line that is tangent to the curve at 2 comma 13 pi divided by 2, find slope. So first step, differentiate both sides, and then substitute the point into derivative. So here, derivative of 10xy. Here we have 10y plus 10x times dy divided by dx, and derivative of pi sine y is pi cosine y times dy divided by dx equal to derivative of 131 pi is 0. Now solving for dy over dx. So dy over dx times 10x plus pi cosine y is equal to negative 10y. And dy over dx is equal to negative 10y divided by 10x plus pi cosine y. Now substitute point. So it's negative 10 times 13 pi over 2. Denominator we have 10 times x is 2 plus pi cosine y is 13 pi over 2. So on top you have negative 10 divided by 2 is negative 5. Negative 5 times 13 pi is negative 65 pi. Denominator 10 times 2 is 20 plus pi cosine 13 pi over 2 is 0. So what we have here, we can simplify. So numerator denominator divided by 5. So on top we have negative 13 pi divided by 4. Now that we have our slope, we can find the line that is tangent to the curve at 2, 13 pi over 2. So here we have y minus 13 pi over 2 is equal to our slope, negative 13 pi over 4 times x minus 2. So y is equal to negative 13 pi over 4 times x plus 13 pi. And now for part B, we have normal line, which is perpendicular to tangent line. This means our slope is 4 divided by 13 pi. So that is negative reciprocal. And our line is y minus 13 pi over 2 equal to slope 4 divided by 13 pi times x minus 2. So y is equal to 4 over 13 pi times x plus 13 pi over 2 minus 8 over 13 pi. So y is equal to 4 divided by 13 pi times x plus 169 pi squared minus 16 divided by 26 pi. So this is our final answer for part B. Find the slope of the curve at a given point. We will use implicit differentiation to find the slope. So here derivative of 6y power 9, that is 54. Y power is 9 minus 1, so that is 8, times dy over dx plus derivative of 7x to the 5th power, that is 5 times 7, so it's 35, times x power is pi minus 1, so that is 4, equal to derivative of 5y is 5 times dy over dx plus derivative of 8x with respect to x, that is 8. So here we want to solve for dy over dx. So here is 54y to the 8th power dy over dx minus 5 dy over dx equal to 8 minus 35 x to the 4th power. So here we have dy over dx times 54y to the 8th power minus 5. That is equal to 8 minus 35 x to the 4th power. Solving for dy over dx, that is 8 minus 35 x to the 4th divided by 54 y to the 8th power minus 5. Our point is 1, 1. So using derivative and substitute this point, we have 8 minus 35 times x is 1. So 1 to the 4th power divided by 54 times y is 1. Here power 8 minus 5. So this is equal to 8 minus 35 divided by 54 minus 5. So the answer is negative 27 divided by 49. So here is our final answer, and that is our slope.